There we go. Perfect. Okay. All right. Oh, I see some people already. Hello, hello, hello. Hello. Good morning. Sorry about a little bit of breakfast here. I didn't really get to eat any, so now I'm having pancakes. But don't worry, that won't hinder me from doing today's lecture. Just a little hungry, though. All right, I think that'll be fun. Good morning, Robert. I hope you're doing well, my friend. I hope you are doing well. Sion, good morning. Good morning there. Um, I hope you. I am doing very well, Robert. Very well. See, I'm hoping. What I'm hoping for is that, um, and I've had good results so far. So I'm crossing my fingers here that hopefully my the buffering issues that we've been running into will hopefully go away. So hopefully I've finally figured it out about how to resolve much of the buffering things, and we can have a nice smooth stream. He's a good morning to you. I hope you are well. How are you? Wow, that is really, really sweet. Oof. That's pretty high sweetness there. Ooh. I'm doing very well, Hisa. I'm doing very well. I was saying, hopefully that we've taken care of the buffering issue. Hopefully that won't be too much of an issue now. So more tweaks have been made. More tweaks. And if I get a good stream, if I get good smooth streams here for the next few days, then I'm going to be in really good shape. So I know this is going to work. I definitely know this is going to work. All right. We're going to get started here very shortly. We're going to start in just about a minute. We'll see if anybody else decides to come in, and then we'll get going. So, should be easy peasy lemon squeezy. At least I hope so. Good morning, Carissa. How are you? Wait, they evolved flippers? Hmm. I'm doing well, Carissa. I'm doing well. Let's see, David's like, flippers? Hmm. That is rather interesting today. Now I got to come up with a fun fact of my own. Hmm. Oh, Daniel. Apologies on that. Sorry about that, my dude. That's my fault for having a bunch of people. Oh my gosh, like 200 people that I happen to talk to on a weekly basis. Uh, Sorry about that, my friend. Accept my humblest apologies. Samantha, good morning. Good morning, Samantha. Let's see here. Let's see here. Fun fact. Yes, I'm gonna put this in. Let's see. I got one for you, Daniel. I got one. There we go. All right, there's my fun fact of the day for you, buddy. I got you. I wish I could tell you, but it's true. This is the way how math can manipulate when you remove people from said calculation. All right, we gotta get going here. All right, let's do this. All right. Okay, let's get started today. Welcome back to. I'm so sorry. I didn't mean to start in such a bleak way. It's what I could think of at the top of my head. Okay, welcome back to Thursday, end of the week time today. So today, all right, today we are going over the latter half of section 4.5. We're going to be doing a lot of different types of examples here today. Um, so if we recall what we did last time we talked about how to divide decimals by whole numbers. So we did problems like this where we said, okay, you take 10.22 divided by 9. We took things like that. What is the there's a Maricela, there are no quizzes for this class. Only homework, tests, and a final. That's it. Like understand that whatever I put in the syllabus there, that's exactly how the rest of the class is going to go. So if I don't put quizzes on there, then there are no quizzes. Done. Easy peasy lemon squeezy. Yeah, you don't have to worry about the quizzes stuff. No big deal. All right. So, we talked about last time about how, again, we divided by whole numbers here with decimals. Today, um, today what we're going to be doing is we're going to be dividing decimals with decimals. All right, so we're going to be dividing decimal numbers by other decimal numbers. And we're going to talk about the step-by-step process about how to go ahead and do that um, by hand. All right. So I'm going to do this problem here first. So I'm going to write this one out. Okay, so this is kind of a lot of for us to do here today. So let's talk about these type of problems. All right, so let's start off with 0.003. Divide that by, we'll have 27.69 divided by that. Okay, so let's take a look at this problem here, and we'll talk about the step-by-step process about how to put this together. Okay, so let's take a look here at step one. Okay, so we're going to go over this very carefully here, so please follow along. It says move the number of decimal places to the right on the divisor. Now, if you remember here, the divisor was the number on the outside. So this, just really quick here, again, remember that this number on the outside here, this is the divisor. As many as you can until we get a whole number. So we're going to move the number of decimal places to the right on the divisor, so the number on the outside, as many to the right, as many as we can until we get a nice clean whole number. Remember what we did last time. It was pretty easy for us to go ahead and divide out by nice clean whole numbers because all we had to do was say line up the decimals and do the regular division. And that turned out to be just fine. All right. In this particular instance, again, we want to be into that same situation. That's why we go ahead and we want to say, okay, let's move some number of decimal places to get a nice whole number. So that's what we're going to do here as well. So we're going to move over to the right here. So step one here is we're going to move over to the right. We're going to move over 1, 2, 3 decimal places to the right. So here on the outside, we get 3. Okay. So this was 3 decimal places to the right. Okay. So on the outside number there, we're not stopping halfway. We're going all the way out until we get a nice clean whole number that we can divide with. Okay. Now let's talk about step 2. Okay, now step 2 is very important here. Okay. So step 2, we move the same number of decimal places as we did in step 1 to the right of the dividend, aka the number on the inside. So again, this guy here, 27.69, this is our dividend. Okay. Okay. Now, sometimes what can happen here is we can have blanks if we move to the right. So if we have blanks, we just put 0 in those places. And then I put a second note here, add the decimal point and any extra zeros as necessary as part of the problem here. So let's take a look at this problem here for step number 2. Okay, for step number 2. Let's look at that one. Okay, how many decimal places to the right are we moving inside in this particular instance? How many decimal places are we moving on the inside here? Okay, that's right. Remember what we talked about before, okay? Now this will be very helpful here. Remember what we talked about before. What we talked about before was anything in algebra always revolves around one thing, and that is talking about the word balance. If we talk about the word balance, then we understand how algebra should work pretty much overall, all right, from a general point of view. So to achieve that balance here, that's why it's also 3 as well. Notice we move 3 on the outside, we got to move 3 on the inside as well. Now let's see what happens when we move 3 decimal places here on the inside. So we go 1, 2, 3. So our decimal point is right here, but as you can see here in this particular instance, we do have a blank here. And because we have a blank here, we're going to go ahead and put a 0 in that spot wherever we see a blank. Okay. Hey, thank you for the follow. Appreciate that. So in reality here, what we're going to have here is we're going to have 3 on the outside. And we're going to have 27,690 on the inside. And again, one of the things that we talked about here is that this decimal point, as you see, is all the way to the right. So I'm going to put that decimal point just like so. And then finally, we do the division just as normal. Okay. Okay. Now, I want to actually point out one other thing is any extra zeros as necessary. What extra zeros am I talking about here? Well, those are any extra zeros to the right of the decimal point. So if you need to add extra zeros here, just in case, if this division doesn't, come out even or whatever the case may be, you can add as many extra zeros as you want in order to get down to that point. Okay, so it just depends on, if you want to add those as kind of practice, some people do. You don't have to put those in if you don't want to. But if you do go beyond the decimal point there for your calculation, go ahead and add a few extra zeros there so you can go ahead and met that out. All right. Now in this case here, let's go ahead and figure this out. So 3 goes into 27 9 times. So we get 27 here, straight up. So you get 0, we bring down the 6. 3 goes into 6 2 times. So that's 0, bring down the 9. 3 goes into 9 3 times. Bring down the 0. And of course, 3 goes into 0 0 times, and that's what we're looking for there. So our final answer here, again, we line up those decimal points, by the way. Our final answer here is 9230. That's going to be our final answer for this problem. All right. Are there any questions about that so far? Hopefully that's pretty chill so far. All right. Remember, everything is always a balance. So balance, 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 and more balance. Yeah. All right, let's try another problem. All right. So let's try another example here. So this time I want you guys to give this problem a try. So I want you to give, I'll go ahead and plop this in at the very least though, so that way you guys can give it a go. All right, so we're going to do letter B here. So we're going to have 0.06 here on the outside. And 1.8072 on the inside. So 1.8072 divided by 0.06. Okay, so let's give that a go. Okay, so I'll give you like a minute or two or so. And let's go ahead and give it a try. All right. and then we'll do it together. Let's give it a try. Yeah. Okay. That is correct, Carissa. Remember, if there's anything you're going to remember in this class, from this class forward, Carissa, anything, it's going to be the word balance. If I do it on one thing, I got to do the same thing on the other thing. That's why we're moving the same amount of times. That's correct. I'm going to tell you right now, that word really helps a lot of people. That helped me too. When you understand that balance is pretty much like the backbone of all of algebra, really, it this subject becomes a lot easier to understand. That I can guarantee you. Got some 30.12s. Look at that. Gee, you guys are fast. Man, first class wasn't as fast as you guys. Oof. All right. Need a little more sugar. All right. Okay. Let's uh let's give it another 30 seconds here. At 30.12s for those. Well, that's good. All right. If you didn't get 30.12 or again a possible answer, that's fine. We're going to go over this together. We're going to see what we get. All right. So in this case here, let's take the 0.06. Let's go ahead and move this over. We're going to move it 2 places here. So 2 decimal places here in this instance. So we're going to have a 6 on the outside. However, that means we also move 2 decimal places here on the inside as well. So we move 2 decimal places here. And so we get here a 6. And on the inside here, we get 180.72. Again, if you feel that it's necessary, and some people I see do this same practice, so again, they may add a couple extra zeros. Again, it may not be necessary whatsoever, but some people do just in case. So, all right. So 6 does not go into 1, but it does go into 18 3 times. So we get 18 here. We get 18 minus 18 is 0. Bring down the next 0. 6 goes into 0, well, 0 times. Oh boy. So we have 0. We're going to bring down the 7 now. Now remember, we're still going to do the same thing here. We're still going to line up our decimal points. So that part is not going to change from what we talked about last time, is the decimal points still line up the same way once we do all the movement stuff around. 6 goes into 7 once. So that'll be 7 minus 6, which is 1. Bring down the 2. And 6 goes into 12 2 times. And so we get 12 here with a remainder of 0. Okay, and so the correct answer is indeed 30.12. That's correct. Very good. Very nice. Okay. Any questions about that? No. It's no. I was like, I got this. No problem. I'm the coolest kid on the block. Okay. I believe everybody. All right. Well, you guys are definitely doing really well today. It's a little bit of a slugfest for the first class, but you guys are buzzing along pretty good. So you guys may actually end up a little bit ahead of the first class there. So, well, let's take a look at some other examples here, and let's see what else we're working with. Okay, so next we have 7 divided by 1.3. Okay, so that's what we're going to do here. Now, by itself, this problem isn't too hard to figure out. Okay. All right, so here we got, again, 1.3 on the outside and a 7 here on the inside. Now, one thing I do want to point out in regards to this problem is sometimes when you see this problem, this can be a little bit rather confusing about where to start with. Now, if you're not sure, I did put a note in here about whole numbers. So the note says, put a decimal next to a whole number on the right if you are dividing it, so that way you know where to start with your decimals. Meaning to say, before you even start the problem, if you have something like this, 7 divided by 1.3, just go ahead and put in that decimal right next to that 7. So that way, if you're going to be moving right by that many decimal places, at least you know exactly where you're going to be starting from, and then move right accordingly. Okay. So it doesn't necessarily tell you in the problem, it's not written out, but that's why I go ahead and make that note so that way you're aware about how that'll work. Okay, so here we're going to be moving. Sure, go for it, Samantha. You know you could ask questions at any time, and I'll be happy to answer. Oh yeah, I forgot to send those to you, didn't I? Shoot, thanks for reminding me. I totally forgot about that. Okay. Yes. Yes, shame on me. That is a shame on me. That's a shame on me moment right there. Um, yeah. You have a right to call me out on that. No, no question. I accept my transgressions and my accountability. I'm so sorry about that. Yeah, I'll send you some. I'll send you the notes that I did find over because I didn't send you anything. Now that I think about it, so um, yeah, you definitely are owed those. Shame, shame me. All right. All right. So here we're going to be. I gotta do this problem now. All right. Now we gotta do one decimal place here. So we're gonna move it over one spot. So we're gonna put a 0 here. So we got a 13 here and a 70 here. Now, what's the difference between this problem and other problems? Let's talk about what that difference is. In this particular case, the difference that we're going to see in this problem and other problems is going to be like so. we may need the extra decimal places or the extra zeros here on the right-hand side. So notice I just said, hey, this is optional. And it still is optional here. But you may need to go beyond that, again, just to kind of say, okay, hey, maybe I need to go ahead and figure out what the extra decimal places are. So let's go ahead and do this problem out. And let's see what we get here for 7 divided by 1.3. Now 13 goes into 70. How many times does 13 go into 70, by the way? How many times? How many times does 13 go into 70? How many times does 13 go into 70? 5 times. That is correct. Okay, good. So we have, excuse me, we have 5 times 13. That's 65. We'll put that point right there. So here we're going to get 5. We're going to bring down the 0. 13 goes into 50 how many times? 3 times, that's correct. Okay, 3 times 13 is 39. So we're going to get 11 here. Bring down the next 0. All right, so here's a tough one here, but not too tough. But 110, 13 goes into 110 how many times? That's right, 8 times. Now, if you didn't get that right away, that's okay. You could do 110 divided by 13 on your calculator. You're going to get 8 point something something. We don't care about the decimal part, but we do care about the 8. And that's how I know it's going to be 8. Now, if we do 8 times 13, that's going to be 4. And then we get 10 here, so that's fine. So subtract, we get 6. Bring down the 0 here. And 13 goes into 60, we'll say 4 times. So that'll be 52. Now, what I'm going to do here is I'm going to stop right here for just a second. Okay, I'm going to stop here at this part. I could add more zeros here because definitely there's more to do, right? Because again, we have 8 and then we bring down the next 0. That's 80, and then we keep going for as long as we need to go. But this can happen in these type of problems here. So what's the difference between, say, this problem and, say, the other couple of examples that we did from before? In those other couple examples we did from before, those pretty much stopped and then we had an answer like 30.12, for example. In this case, this can probably keep going for as long as you like. So one thing that we're going to be on the lookout for is, let me go back to this here for a second, is that sometimes we may need to round the answer here. In this case, let's say we round to the nearest hundredth. Okay, all right, so let's say, so let's go with that here. We're going to round to the nearest hundredth. So we did talk about rounding here last time, okay, with decimals. So we're going to once again talk about it here as well. Okay, so let's take a look here. So we have 5.384. Okay, so if we're rounding to the nearest hundredth in this problem, can anybody tell me, in this number here, 5.384, which number is in the hundredths spot? Which number is in the hundredths spot? Okay, that is absolutely correct. The answer is indeed 8. 8 is in the hundredth spot. So because 8 is in the hundredth spot, we look to the number to the right here, okay, which in this case is 4. So does this round up or does this stay the same? Does the 8 round up or does it stay the same based on our rounding techniques? Yeah, that's right. It stays the same, right? 0 to 4 stays the same. 5 to 9 will round up by 1. Okay? So this 8 will just stay the same as 8. So if we round here to the nearest hundredth, we're going to get 5.38. Just straight up, just like that. Again, this 4 would change to a 0 when you round. So this basically kind of, if you want to effectively drop that out. So 5.38 would be your final answer for this problem. Any questions about that so far? Okay, this time I'm going to have you guys try. So let's try this last one here. This one's a pretty challenging problem. But you guys are hopefully up to the task. So let's go ahead and give it a go. By the way, just to help you set this up, at least to start with, remember that if we divide by 6.2, remember that 6.2 goes on the outside here, not on the inside. It's not always bigger divided by smaller. It's just, again, what comes first and what comes second. Okay, so let's take a minute or two and let's go ahead and do that one out. And yeah, we'll see what we get. Again, if this is an uglier one, round to the nearest hundredth once again. So I want you to do the same thing you did here for the previous problem. Round to the nearest hundredth. And once you got an answer, go ahead and post that in the chat. How to how to complete homework faster? I'm kidding. I'm kidding. I'm doing very well, flexing. I hope you're doing well. I'm doing very, very well. I hope you're doing very well. Or if there's something bothering you, let me know. That's good. I'm happy to hear that. I hope things are okay overall, at least academically or personally. Either way. Obviously, I mean I can if you like. You can sit in here and just you can ask questions or uh just listen. It's up to you. I'm don't force any situation on anyone. So, all right. How we doing, guys? Left hand side, right hand side thing? Are you talking for algebra there, flexing? Okay, I can do that. Let me go ahead and I'm going to do this problem here, and I'll go ahead and explain that to you. That's not a problem. Okay, no problem. Once you get it down, it's really not too bad. I promise you that. Okay, so let's go ahead and finish off this problem here at the very least. Now, this one here was a little bit of a tough problem, I'm sure, for all of you. So let's go ahead and do this one out. And for you, flexing, I think this will actually be very helpful for your question as well, um, in one regard. So, although we're doing a decimal here, again, we're going to be moving this over to the right by 1. We'll move this over to the right by 1 as well. So hopefully everybody got the 62 here on the outside. Yep, that's right. That's why it's a tough problem, though, Samantha. To be fair, it was intended to be a tougher problem. So was not a super easy one. So, but at the very least, you guys got this. So 0 point numbers is at least the framework of the correct answer. That's true. um, okay. So we're just going to see how many times we get here. 62 does not go into 53, so here we get 0, just outright 0. Now if we subtract, we get 53, and we could bring down the 0. Now what you could do next is what we're going to be looking at in subsequent examples here today, and that is we want to figure out how many times 62 goes into 530. Now that's kind of a tall task in some cases because obviously 62 is a pretty large number. So just go ahead on your calculator here. You're going to do 530 divided by 62, and you're going to get a number here. Doesn't really matter what the number is. You'll get 8 point something something. 8 point numbers. I'll use Samantha's terminology. All we care about is really the 8. Okay, we don't care about the decimal side there. We just care about the 8. Then we just do the same thing here. 8 times 62, and rinse and repeat said process. We get 496 here, if we actually do that out. And we have 530 minus 496, which will be 34. All right, and we will bring down the 9. Again, you can repeat that on the calculator there. 349 divided by, again, 62. We get 5 point something. Again, the only thing we care about is the 5. So we do 5 times 62. And here we get 310 if you multiply that out. Here we get 39. I'm going to bring down the 1. Again, do the same thing here. 391 divided by 62. We get 6 point something something. So that's okay. And so we get 6 times 62. That's 372. Okay. Now, obviously, we could keep going for as long as we'd like. Again, you know, may not end up with the decimals here. This could keep going on forever and ever for all we know. But we want to round this to the nearest hundredth. So here we have the decimal here, 0.856. What does this round to here? What does this round to here if we're talking to that 900? 900. What? Okay, really quick, everybody. What number is in the hundredth spot? What number is in the hundredth spot? Okay. I was looking at 900. I'm like, okay, I see where you guys are trying to go with that. But remember, the number, this is the tenths, okay? This is the tenths. This is the hundredths, okay? So remember how it goes. It goes to the right of the decimal here, everybody. Tenths and then hundredths. Remember, for decimals we skip. That's okay. That's why we ask the questions here, so we get the understanding here. So 5 is the number here in the hundredth spot. And 6 is the number that we're going to check to see if we bump it up by 1 or we keep it the same. In this instance, we want to go ahead and bump this up by 1 because the 6 is between 5 to 9, so we up that circled number there by 1 to 6. So this is where we get 0.86 as our final result there. So really quick here, does that make sense? Is there any questions about that? Hisa, Samantha, does that make sense why it's not like 0.9? That's why it's 0.86 here. I know where you guys were going with that. It's just that I just looked at the wrong number there. That's all. Yeah. All right. Now I'm going to do a... Now, remember, the biggest key in this problem here, and this is also for you flexing as well, the biggest key in this problem, again, was just apart from the rounding, is if you saw here flexing and everyone else, again, we moved 1 decimal place to the right in both cases. Like flexing, if you want to understand how left-hand side, right-hand side kind of works with regular algebra, I stressed this earlier. I know you weren't here earlier. That's fair. The one thing that you should always remember here, put this in the back of your mind. Okay, even if this is this is pre-algebra, but still for pre-algebra, algebra, calculus, college algebra, whatever you want. Okay, it doesn't really matter. High school math, it really doesn't matter. The key word here to remember in algebra is always the word balance. Always remember the word balance. That is the first and foremost thing that should be in your mind. How do I balance things out? Okay, if I'm trying to solve for something, I need to balance things out in order to get to that result. That is basically the word that you're going to have to learn to kind of get to know how to get to that final result that you're looking for. Okay, so that's the first word I want you to think about in your mind here. So if I were to show off a problem here, and this is a good preview for you guys as well, because you guys will be encountering these type of problems here actually in the next class up. So let's do a sample problem here really quick, and it will showcase how balance is actually even more important than of course, just doing these decimal type of problems. So let me go ahead and showcase a nice small little problem, and we'll see exactly how this works out with the concept of balance. So let's say I had something that looks like this, okay? So let's say I had 3x minus 5 is equal to 7. Okay, and I asked everybody here, I said, okay, hey, can you give me a number that if I plug it in for x, right, if I plug it into this random letter, whatever that random letter is, I don't care, that somehow if I subtract that, if I multiply that by 3 and I subtract 5 by it, that automatically I get 7. That's what I want. Okay, that's what I want. Now, let's think of it this way, okay? I need to balance things out, okay, in order to get to x by itself. So let's think of the goal here, right? The goal here in these problems, and what all of you are going to see later on in future classes, is we want to get x by itself. So just get x by itself. So all that means is that, okay, I want x is equal to some random number. Okay, that's all I want at the end of the day. I don't care about anything else. This is all I want. I want x is equal to some blah, blah, blah number, whatever it is. Okay, so let's think in that mindset. That's what I want. Now, I need to be able to get there, but I don't quite have that just yet. Okay, now here's the thing that's in my way. Okay, I have some roadblocks that are in my way. As you can see here, I have this 3 that's in my way. I have this minus 5 here that's in my way. Okay, those are in my way, right? But if I can get x is equal to numbers, then maybe what I can do is this. Maybe what I can do is this, is that I can have the x's on one side and I can have the numbers on the other side. So I got, like, let's say I have on one side, left-hand side, right-hand side, it doesn't matter here in this case, but I want letters on one side, I want letters, and I want the equal sign, and then I want like numbers. Okay, this is what I want. This is like the basic template that I'm thinking about in my mind. I've said, okay, hey, I want letters over here and I want numbers over here, because I'm just thinking in basic concepts. I'm like, all right, I know how to deal with some letters here and I know how to deal with some numbers here. Okay, then that's not too bad. Okay, I can think about it that way. Now, in order for me to get numbers to one side, this is what we have to do. So, to kind of help ourselves out here in this particular case, is if you see this minus 5 here, all right, this minus 5 here in this particular instance, all right, is we're going to go ahead and say add 5. So we have one thing that you'll see here is a lot of this balance stuff that we talk about. When we want to move this minus 5 to the other side, we take the opposite of minus 5, which we'll talk about later here, by the way, in chapter 9, is we're going to plus 5 here as well. But remember, we talked about balance here. So if we add 5 to this left-hand side, then we also add 5 to the right-hand side. So here we actually end up with 3x is equal to 7 plus 5, which is 12. So let me go ahead and put that down here. So right now I have a number with a letter on one side, and I have some numbers here on the other side. Perfect. Now I want to solve for x. Now to do that, I have another roadblock in my way. My other roadblock is this 3. I have 3 multiplied with x. Well, if you notice what I did up here, I did the opposite, right? I did say -5, and the opposite is +5. Well, really quick here, and I know you guys can answer this question. What's the opposite of multiplication? What's the opposite of multiplication? Yeah, that's right, right? Isn't the opposite of multiplication division, right? We know that, right? If we know right? We know that the opposite of minus is plus. So we know that the opposite of multiplication is division. So, okay, let's balance it out, right? That's what we're thinking about. We're thinking about balance here, right? So let's balance it out. I'm going to divide by 3 because if I need to get rid of that 3, okay, all right? Now that's the opposite of multiplication, so I'm going to divide by 3. But what else do I have to do then? What else should I do then? If I divide the left-hand side by 3, what else do I have to do? What do you think? That's right. That's right, right? Doesn't it make sense? We always think about balance, right? We divide the right side by 3 as well. Exactly, right? Always balance, ladies and gentlemen. Always balance. Okay? That is like the biggest key in this class. I guarantee you. And so 3 divided by 3 is 1, so that's fine. And so we get 12 divided by 3, and that's just straight up 4. And that's actually how we end up with our answer for x. Like, I'm not going to guess. It's 4. That's kind of how algebra is going to go for you guys. This is what balance provides to you. This is why that word is the most important word in all of algebra, in my estimation, is because it helps you understand what the steps you need to take in order to achieve that balance in any problem that you're trying to do. There are different ways to do that balance, but again, you're always thinking what I do on one side is what I do on the other side. What I do here is what I got to do there. This is basically the backbone of all of algebra. And this is a good preview about what you're going to see here in, say, 96 and 98, things like that. This is a very, very good preview for that and a very valuable lesson. So, yeah, this was a good question for sure. So you'll see this later on, maybe not necessarily in this class because we're just kind of getting our basics underneath, but this gives you a good preview about what you'll see later on. So I think an excellent question. Anybody have any questions about that? So I hope you can understand now why I'm so adamant about the word balance and why. Why? Now you can understand. Now you can understand the why I actually stress balance so hard in this class. Is true, Samantha. Is because of that fact. Is because without that concept of balance, I didn't understand how algebra worked before that point. Like, I had a really hard time with it. I had a tough time with math for a while. So until I finally started to put it together, yeah, then you know, this was one of the things that really helped me out too. So this is part of my personal struggle with mathematics. This is very true. Definitely helps with percentage. Absolutely 100%. Indeed. Yes, that's my terrible pun, and I'm sticking to it. Math sucks. Math is terrible. Oh, I see how it is. I see how it is. Okay. Are numbers not useful in your life, Samantha? Is that how it is? Are numbers not useful in your life whatsoever? No? They're not useful at all. Good. That's fine. Give me your purse and social security number. You don't need those numbers at all. I will take them, sure. I'll be happy to use those numbers. But since you only need a calculator, that's fine. All the rest of the numbers that you have, don't worry about it. They'll be safe in my hands. Okay, pat pat pat. All right? Definitely safe in my hands. I'll be happy to use them at any time. No problem. I mean, hey, look, you didn't need money. You just want the calculator. Here's your calculator. I'll just take your money. I'll just take your credit cards. I'll just take your social security number. I'll just take everything else that has numbers associated with it, you know. And I'll be like, "Here you go. I'll give you the calculator. Congratulations. There you are. You got your calculator." That's all you wanted. That's all you needed. I know. Take your debit card, you're broke? I'll be happy to take your debit card and absolutely trash your credit. That is not a problem. Even if you're broke, I could still find a way to trash your credit using mathematics. And then when you try and buy a car, you won't be able to buy a car. When you try and rent an apartment, you won't be able to rent an apartment for yourself. When you try and buy a house, you won't be able to buy a house or get a ridiculous interest rate which you can never pay off. Mm-hmm. Numbers. Now, personally, I really don't want to do that to anybody. That's a terrible thing. Thank you very much. You want to know the most embarrassing thing that can happen? Real life? The most embarrassing thing that can happen is that if you are trying to rent an apartment for yourself or anything like that, and that you have to get a guarantor to sign off for you because your credit is so bad, it's like, I want to do this myself, and then you realize you can't because you screwed up about your spending habits well beforehand. Yeah, that's a problem. You always should fix your credit and be like, you know what? It says I want to be independent, but it's like, no, I go back to mom or dad to sign off on having me rent this apartment. You kind of feel bad about that. I'd rather give you tips and tricks and let you learn how to do math to be like, hey, how can I improve my credit score? How can I get better? How can I make more money? How can I do that? So, all that stuff is super important. Definitely worthy of math related things. Yeah, a credit card can be a little bit tough to work with when you work with it for the first time. I got my first credit card when I was 30 years old. So I got mine really late myself, as much as you did, Anna. Um, yeah, but I learned kind of tips and tricks in order to help myself out, in order to get to use that properly and to get the proper credit score. It took me a long time, though. Admittingly, it took me a good it took me like a good 2 to 3 years to finally get my credit score up. My credit score went from like when I came back from Japan, my credit score was 530, and then after 2 years of very crafty planning, after 2 years, I got it to 730. So It was only thanks to my friend that I could pull off the crafty planning, though. So that was not done on my own. My friend gave me a lot of tips and tricks that I was using in order to move up the ladder there. All right, let's do another example. We got, man, that's right. I got another examples to do. All right, estimation time, ladies and gentlemen. Let's do some estimation. Those numbers mean nothing to you. They may mean nothing to you right now, but they'll mean a whole lot when you decide to go independent. This is, I can guarantee. Like knowing what your credit score is and trying to get the things that you want for yourself, yeah, those things are going to, that credit score is going to be very important, and it's going to be very important that you learn how to maintain a debt. Maintaining a credit card and maintaining a debt is very important. But let me do this here, and then I'll explain a little more. Okay, next, we're going to be talking about estimating. Let's talk about estimating here. Okay, so for estimating here, we're going to be talking about front-end rounding. Now, for front-end rounding, what does front-end rounding means? The key is to look at the very first number and round to that particular placeholder. So let me go ahead and copy this down here, okay? And so this basically says here we have 580.44 divided by 2.8. Okay, so 580.44 divided by 2.8. Now we're going to round each number here using the very first number that we see and round to that particular place. So that pretty much means, like in this particular case, what we're going to look at here is we're going to look at the 5 here to start with. So when we say that that's the first number we see, that's the front end rounding that we're talking about. So we want to round here to the nearest 100, since that's the hundreds placeholder in this case. So what can we round 580.44? What can we round that to? What does 580.44 round to? 600. Very good. That's right. So again, we look at the 8 next to it, and this will round to 600. Again, we're just getting an estimated answer, and then we're just going to find the exact answer here. Okay. And then let's look at 2.8. We're going to look at this. Okay, the 2 here is the first number we see. This is going to be the nearest ones. Okay. Okay, so what can we round 2.8 to? What does 2.8 round to? 3. Okay, good. So here we're going to do 600 divided by 3. Now if you do 600 divided by 3, that's actually pretty easy as an estimated answer. That's going to be straight up 200. Again, I'll leave that to you to go ahead and figure out. So 600 divided by 3 will equal 200 here at the end of the day. So our answer should be estimatedly close to 200 in some capacity. Let's go ahead and figure out how we can actually see that final answer at the end of the day. So we want to see the exact answer here. That's going to be the next part. So we got 2.8 and on the outside, 580.44 on the inside. Again, we're going to move over here 1 decimal place to the right. So we're going to have 28, and then this decimal place goes here. Again, we moved it 1 decimal place to the right. So 1 decimal place. And this is also 1 decimal place. Okay, so we're going to get 580, 580, sorry, 5,804.4 is what we're going to have here. And then all we're going to do is do our division from there. So let's go ahead and see what we get. Okay. So 28 goes into 58. How many times does 28 go into 58? How many times does 28 go into 58? 2. Okay. So 2 times 28 is, if you do that out, that'll be 56. That's right. Again, you can have the calculator help you if you're not sure. You can do these calculations pretty quick. Again, you do 58 divided by 28, and you'll see that it's 2 point something. Just take the 2. Take the 2, bring down the 0. 28 does not go into 20, so that's going to be 0. All right, so we're still going to have 0 here. Subtract, we got 2, 0. We're going to bring down the 4 here. All right, again, if you need to add zeros here, you can. 28 goes into 204 how many times? How many times does 28 go into 204? All right, 7 times. 7 times, very good, that's right. So we're going to put a 7 here. 7 times 28 is going to be, that's 56, and that's 196, okay? So that's going to be 8. We're going to bring down the 4. We already put the decimal in its spot. So 28 goes into 84 how many times? How many times does 28 go into 84? 3 times, that's correct. So here we get, again, 3 times 28 is 84, and thus we get a remainder of 0. Okay, so our final answer here is going to be 207.3. That's our final answer. Okay. And that's our final result. Perfect. Again, how do you know? So again, one thing that you can use here is, let's say you're doing 204, right? So for example here, on your calculator, do 204 divided by 28. Okay, so just do 204 divided by 28 on a calculator there. So now what you're going to see on the calculator is you're going to get 7.285 ... Okay, that's what you're going to see, like this. Throw out the decimal part and keep the 7. Okay, that's what you're going to do. That's what we did here. We threw out the decimal part, we kept the 7. Then do 7 times 28, which is equal to the 196 that we have here in this part right here. So this was the 7 times 28 part right here. So that's a good way to kind of like basically say how many times a particular number, because you could be dealing with like really large numbers, like 354 or whatever, and that takes a long time to do, and I'm not expecting you to take like all day just to figure out how many times a very large number goes into another very large number. So we're trying to basically shorten the process down as best as possible. Does that make sense? Okay. So I hope that makes sense there, Samantha, though. Any other questions? Okay. Any other questions, anybody? No? Okay. All right. So that is where we're going to stop here for today. Okay. Now, next time, we're going to do the last part of this section here, which is order of operations. And again, order of operations for decimals is no different than regular order of operations. Again, it's the same thing as we talked about before. Again, parentheses, exponents, multiply, divide, add, subtract. So again, you're going to be using the same rules for multiplication of decimals, okay, and division, okay. Same deal. Everything is pretty much exactly the same as it was before. Okay, so no difference on how we're going to approach that, but we're going to do like one or two examples from the end of this section here. Now, that effectively, once we're done with that part there, will be effectively the end of chapter 4. But the next test here, by the way, is not just chapter 4. It'll be both chapters 4 and 5, because chapter 5 here is going to involve with stuff here from chapter 4 and a little bit of chapter 3 as well. So the test here won't be for a little bit, so rest assured that we're not having a test here next week. It'll be the chapter 4 and 5 test here once we get done with chapter 5. Okay, so that's what's on the agenda here, at least moving forward. All right, so that's what we have going on there. And here's a fun fact to end you guys off for the weekend here. Fun fact. So homework here is going to be, sorry, homework is section 4.5. Okay. So if you want to keep up to date, homework is section 4.5. All right, here's a fun fact. This goes out to Anna. Lying on your credit card application is a great way to build credit. Fun fact number 2. Fun fact number 2. I never told you how I lied on my credit card application. I understated my income. I actually didn't over. Now you probably say people lie like, "Oh, I make more than I actually do." No, I actually went the opposite way. I understated my income on my credit card application to get the lowest credit limit possible. That's what I did. That's what I wanted. I wanted the lowest credit limit possible. The reason why I wanted to get my lowest credit limit possible is because one of the techniques that my friend taught me is like saying, okay, if you want to start building up your credit score, get the lowest credit limit possible. And then in the very first month, you start establishing a pattern because that's how credit card companies apparently look at you. They talk about the pattern that you can establish from month number one. You could be like, have a great afternoon, Hisa. Um, is basically they say, hey, okay, what are your spending habits? So what I do is I spend it to the max the first month. It was $500, and $500 is very easy to spend to the max and pay off. And so what I did was it's like, okay, I spent my credit limit of $500. And then I went ahead and I paid $450 out of the $500. That way I kept at a 10% threshold or below of my credit limit. And that way, basically that told that the credit card company through their algorithm slash calculation system that, oh yeah, you can maintain a debt because you still have a debt on your record of $50, and then you paid it down to the threshold that gives you positive points. So I was like, okay, that's cool. And then all you have to do after that is use it once a month, and then you could just pay it down to the 10% of your credit limit threshold, which is super easy when you have a credit limit of $500. How many times have I gotten rejected? Never. I only applied to one, and that was an intentional starter card. So the one thing is that if you want to apply for a credit card there, Anna, apply just for a starter card. Okay, that's all I did. I didn't go for like the super premium stuff there. Okay, no, 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 no. I understand my income and I told them, hey, give me whatever interest rate you want. I don't really care because I want a low credit limit. I want the lowest that you got. I'll understate my income. You give me 500 credit. You give me 500 bucks as my credit limit. I can manage that. You can manage that. I don't need to worry about that credit limit. Now, over time, you'll see that it starts to work because what you'll get is in your mail, you'll get more credit card, possible opportunities. So you get more junk mail. You'll also see your credit limit possibly going up. So my credit limit went from 500 to 1,000 to like 2,000 in a matter of like, 4 or 5 months. And I saw my credit score start to improve little by little. Notice it wasn't like a big jump here, but my credit limit now, it went up to 2,500, and then now my credit limit's at $5,000 for that same credit card that I got all those years ago. Now I don't never spend $5,000 on that credit card whatsoever. Trust me, I barely use my credit card. But the thing is that in order to start building that credit, I started from the very bottom instead of working from the very top. Because when you have the top, then they have high expectations. If you work from the bottom, you have lower expectations, but you have an easier time of getting more positive progress on your credit score. So that's the reason why actually lying in terms of understating my income as opposed to overstating my income was actually much more beneficial for me, because at the same time I was able to go ahead and pay off my other debts, which then added even more points. So whatever debts that I had on my record, I just called collection agencies like, hey, let's get rid of this stuff, old medical bills, old stuff. Let's get rid of that stuff. You know, got it cleaned and wiped off the record. I paid like one legal agency away to just send letters and say, hey, I want this. I want you to say, hey, this is paid in full. Get that clean and wiped off my record, and start building up points from there. It's a slow roll. It took me like 2 years, but it worked. It worked, and I was able to get a car for myself. I was able to get buy a house for myself and stuff like that. So um, without question, it did indeed work for me at the end of the day. Yeah. So what you should do, Anna, is that yeah, if all you're doing is paying for gas, okay, go start at the bottom. Like get a starter card. Say, hey, I'm just trying to build up credit. You can tell a credit card company who says, hey, I want a starter card. I'm just trying to build up credit because I've never had a credit card in my life before. And they totally understand that. They totally do. They'll charge you more because they don't know how you handle your credit, but they're like, okay, whatever. You're like, okay, whatever. I'm not really playing with a lot of money, and I'm not going to. So fine. And so you start off with $500 and then work your way, and then basically use all $500 the first month. First month, that's why you get a low credit limit. It's easy to spend 500 bucks. Use it to the max. pay off 90%. Once you do, okay, then use it and then pay it to 10% of your credit limit and then keep going from there. You could use it once a month for the gas or whatever, and that's it. So, and then of course look into your credit report and then see what other bills or any backlogs of payments that are accidentally on your report that maybe you need to challenge or things like that. You know, start scrubbing that credit report to increase your score if you need to. So there are definitely things that you can do that can certainly help you improve your positioning in terms of your score. So hopefully that was a little bit helpful. Again, you'll have to figure that part out, but again, I hope I can give some advice that can be a little bit helpful for you. Okay, great. And I know you have a good head on your shoulders, okay? So that's why I made you a moderator in the first place. You got a really good head on your shoulders, so I know you're going to definitely do the right thing. That's going to be good for you. All right. All right. I want to thank everybody for coming out here to the stream here once again. Okay. I will be back for college algebra at 4 o'clock, which is 3.5 hours from now, Central Time. Okay. But if I will see you all later, Samantha, I'm gonna get you your handouts there, so I'll send those over to you. Okay. All right. Take care, everybody. Have yourself a very wonderful week or weekend, I should say. All right, and take care of yourself. All right. Have a great one, and we'll see you later. All right, everybody. Have a great one. See ya. All right. Bye.